Welcome to our channel, students. Today we are going to start a very important chapter of class 10th physics, that is light. Let's come to the point. Light is a very important concept as far as physics is concerned. So it's very important to understand the nature of light and the definition of light. Let's begin with the definition of light. Now see, we can define light in several words, in several ways. The technical definition of light is an electromagnetic radiations and can travel through vacuum. See, here we come across two terms. The first is electromagnetic and the second is vacuum. See, electromagnetic means it is composed of two types of field. The first is electric field and the second is the magnetic field. And when these two fields varies with time, it produces a special type of wave that is known as electromagnetic wave or radiation. And the next term is vacuum. Vacuum, we can understand, is a space or a region which contains nothing. It contains zero entity, or you can also say that it contains nothing, but it is an empty space, and therefore it is known as empty space. Or we can describe this space as optically rarer as far as the optics or the light is concerned. Okay, so and I think this is a much technical definition, and this will pose a difficulty in understanding the definition. Let me simplify this definition, and let me define it as light is a form of energy by virtue of which we can see the things around us. I think it is more convenient to you all. It will be very convenient and very easy to understand. And I have tried myself to simplify the definition, and I have just written this definition in my own word. Light is a form of energy which gives or produce a sensation of sight. Okay, now let's move to the nature of light. Now see, in order to understand the light, it is very important to know, or it's very important to know about the nature of the light. Okay, so let's try to understand what light is and what are its characteristics. The first point is light travels in a straight line. It means that it exhibits the rectilinear propagation of light. It means that it travels in a straight path. It never travels in a zigzag manner. Is that clear? Okay. Now, the second point, light exhibits the dual nature. See, it's very important, very vital characteristic of light. See, light has two natures. The first nature is particle nature and the second is the wave nature. The particle nature means it consists of something which or by virtue of which the light exhibits the particle nature or exhibits as a particle, and this is nothing but photon. The photon is the reason due to which it is known to exhibits the particle nature of. Okay, and we will learn about this photon in higher classes. Okay, but for the time being, it is nothing but a bundle of energy. It is bundle of energy or the packet of energy. Okay, and this property of light has been used by Sir Albert Einstein to do his world famous experiment of photoelectric effect, due to which Sir Albert Einstein was awarded Nobel Prize for this only. Okay, and the second nature is the wave nature. It means that it shows the wave nature as well. Okay. Okay, now let's move to the third point. The third point is very simple. It travels with a speed which is approximately 3 into 10 to the power 8 meter per second, or exactly it is about 2.998 10 to the power 8 meter per second, and it has been calculated with this formula. This formula, that is the speed of light, is given by c. The speed of light is always denoted as c, and this c is equal to lambda into mu. This is known as mu and this is known as lambda. And what are they? They are, that is, the lambda is wavelength, wavelength, and this mu is frequency. And I hope this definition of light and the nature of light will be clear to you all. Now let's move to the next topic. The next topic is reflection of light. Now see, the reflection of light, we will learn this topic in a very easy way. Okay, now see, the reflection of light, actually this this topic is not new to you all. You have studied this in class 6th as well as in class 8. So I think this will not be very difficult one. Okay, let's try to understand it in a very simple way. So the reflection is nothing but the bouncing back of light after striking a polished reflecting surface. See, this is the definition of the reflection of light. However, you can understand it through the diagram. Let me see, as you can see here, that here we have a polished, this is polished reflecting surface. Okay, now see, when light from a source strikes at a point, let us consider it as O. When light comes and strikes the polished reflecting surface at point O, it get reflected like this. Okay, so you can understand this as an incident ray when strikes the polished reflecting surface at certain point, it get reflected in a very similar medium like this with certain angle with respect to this imaginary normal line. This is imaginary normal line which is perpendicular to this polished reflecting surface. So let me name this angle as I, that is the angle of incidence, and this as angle of reflection, and it is denoted as small r. Okay, now see, when the light comes, when the light in the form of incident ray strikes the polished surface at point A, it gets reflected like this. Okay, and this is known as reflected ray. And in order to clarify this whole process, there is certain law, and this law is known as the law of reflection. We will summarize this law of reflection in 2 points. The first point is the incident ray, reflected ray and the normal ray and the normal all lies in the same plane. As you can see here that the incident ray, the reflected ray and the normal all lies in the same plane, that is here on the same point, which is on a same plane. Okay, same plane, you can understand that they all lies at a point, at a single point, and this point actually lies in a single plane. Okay, therefore we can say that all the 3 rays lies in a same plane. I hope this will be clear to you all. Okay, now moving to the second point. The second point is that the angle of incidence is equal to angle of reflection. Now in words we can say that the angle of reflection is equal to angle of reflection is equal to the angle of incident. Okay, the angle of reflection is equal to the angle of incidence. I hope this will help you a lot, and thank you so much.